Hello everybody, welcome to the part 2 of this video series of Introduction to Hadoop. Today we'll be discussing the ecosystem, which means the ecosystem components and the various Hadoop distributions that are available to us. So last time we saw that for large amounts of data, we have come up with a storage system called HDFS where we distribute the data over several systems, and also a processing system called MapReduce where we distribute the processing over several systems. Ingenious idea, right? What's the issue? Why is there an ecosystem around it? Why can't this be it? Well, let me walk you through it. There are a lot of issues with the system. The first being the amount of entry threshold to this kind of a system. You have to always look at your problem in the MapReduce way of doing things, right? And that is not always easy to do, and that requires a very specific skill set to do. Especially, it is more difficult if you have a very huge and a complex problem, because then it has to be broken down into very small parts, and each part has to be visualized and executed that way. So this also limits the functionality of what we can do with this kind of a system, right? So entry threshold, the functionality, and third is we barely discussed about the utilization of the framework or the efficiency of the resources that we are using. Are we using them to their full extent? Well, I think not. So, to solve these issues, we came up with many more things which are called the ecosystem and the components. So, these are basically softwares which came about after the Hadoop MapReduce system was developed, and these are there to enhance the functionality, to increase the framework efficiency, lower down the entry threshold, and make it more user friendly. So this is software that you would probably see when you are looking at processing that's related to big data. And the idea of this is we will be going through each of these softwares one by one so that if you come across these in the future, you're able to understand where in the broader scheme of things this fits. What is the functionality of this part of the component? And we cannot possibly cover everything that is being developed for big data or that can be fit into an ecosystem. So we'll be covering a few of the most popular ones. Let us start with the first one, the HDFS. So HDFS is basically the distributed file system format where as we discussed, the data is being stored on multiple systems. And this is basically where the storage for the whole ecosystem is happening. Next, if you remember, we had discussed about the processing that is parallelized. Then, that was called MapReduce. There's something called YARN, yet another resource negotiator, which we'll be looking at later in the course. This is basically known as the MapReduce version 2. This was visualized to be the operating system for Hadoop. The idea of YARN was to improve the scalability, performance, and the resource utilization. So, as the name suggests, yet another resource negotiator, this has to do a lot with the resources and how the applications are running. Let us look at Spark. So, Spark is basically a data processing software. It is very fast. It is my favorite component of this ecosystem. So it has, just like MapReduce, it has its own way of doing things and processing the data in the distributed format. It is built upon the MapReduce ideas, but introduces few very new concepts, like acyclic graph processing or lazy evaluation, which are very useful. So one of other associated libraries also, as you can see, Spark Streaming for data that is streaming, that is at high velocity. High velocity means that data that is coming very quickly and continuously. GraphX for data, dealing with data that is of the graph format. MLlib, which is for the machine learning library, and Spark SQL for performing the regular ETL/ELT tasks. So this is about Spark. So Spark was also basically for processing. Now we have data in HDFS and we have a processing structure on top of it, right? But the data cannot magically appear in HDFS. Of course, there is a way to input the data into HDFS. There is not one way, actually. There is more than one way to input the data into HDFS. So let us first look at Flume. Flume is basically inputting the data that is written in log files. This may be unstructured or semi-structured. Next, we have something called Scoop. So Scoop is actually, if you see the name, it is SQL plus Hadoop. So this actually enables the data exchange between RDBMS systems that is relational database systems, the systems that we have been using tables and those kind of things, into Hadoop systems. And this exchange is what actually enabled the industry to move to this direction of Hadoop. So scope was pretty good. It basically provided great import and export functionality. Like Kafka, Talent, Spark Streaming, these are all softwares that process streaming data which come at high speed. So Kafka is able to push them to HDFS. And we'll see that today there's a rage for Kafka. So this is about putting the data into HDFS, and we have discussed the programming paradigm also. But I told you that the entry threshold is reduced. How is that? Well, for the entry threshold, there was something called Apache Pig that came forward. So Pig was basically used for data analysis, and it was brought about by Yahoo. The language to use Pig was very close to English, which is what helped it in gaining popularity. And it allows you to run queries on your data. Nearly at the same time, when Yahoo came about with Pig, Facebook came about with something called Hive. So Hive is basically running queries in the background in the MapReduce format. So it's like a wrapper around MapReduce. These queries are written in a language called Hive Query Language, HQL, which is extremely similar to SQL. So this was actually very, very useful because we already had a workforce which was working on SQL, and for them to move from SQL to HQL, it was barely a transition, and hence this could be very easily used. And Hive and Pig both are the data warehouse system querying for large data sets that are stored in the Hadoop files. But we have not discussed about the strength of Hadoop, which is the storage of unstructured and semi-structured data, and using not always the relational databases, which it utilizes something called HBase. So HBase is basically a NoSQL or NoSQL database. It is column oriented, and while the data read and write is on HDFS only, but it provides you the real-time usage. So the other open source softwares like Cassandra, MongoDB, DynamoDB, CouchDB, etc., which are also very useful in this context. But in this diagram, I have included HBase, which is very, very popular. Also, one very nice thing is that this HBase data can be accessed using Hive, Pig, and even MapReduce. Okay. Next, we have Spark, MLlib, and Mahout. So these are basically machine learning algorithm libraries. This is to run ML programs on big data. So that is where this comes. Next, we have Ambari. So Ambari was basically a software which is used by administrators to look at what is happening in this cluster or this instance of the ecosystem, and it is used for creating a cluster, provisioning it, managing it, monitoring it. Cloudera Manager, which is of the very similar functionality as Ambari, that is also there in place of Ambari oftentimes. Next, we have something called Zookeeper. So what is Zookeeper used for? Funny name, considering the choice of softwares that we have, and as the name suggests, it is the zookeeper. So it basically manages the cluster internally. If you remember, we have a distributed system, right? So all the variables, there are some variables for which you need a static value. Like every system should be accessing the same value for the variables, right? And that is what Zookeeper does. By using these variables, it allows you to manage the cluster. So it is mainly used for coordination and synchronization. It will maintain the configuration information, naming of the distributed file space, synchronization of these things, and then providing groups and services. Okay. Lastly, we look at Uzi. So Uzi is a very simple job scheduling framework. It just defines the workflow and the order of execution. When you are submitting the pig, hive, MapReduce, and scope jobs, it will schedule them on a regular basis. So now that we have seen the ecosystem, we can appreciate the fact that the companies can drive more use out of the softwares which are built on top of Apache Hadoop and MapReduce, like Hive, Spark, Scoop, etc., than directly Apache Hadoop and MapReduce. But imagine there are so many services and you have a cluster and you need to set up each one of them. And not only that, you also need them to be integrated and configured to work together. This is a huge task. And hence, there are these companies which provide something called Hadoop distributions. So these are basically a collection of softwares which are together configured and integrated and can be directly deployed on your cluster. This way, you will be able to utilize all these services at once without the hassle of actually going and configuring them. This is possible because most of the source code of these softwares are open source. So now let us look at few of the distributions that are widely used. So we'll be first looking at Cloudera. Cloudera is basically the oldest and the most developed distribution. It has the maximum market coverage. Most of its tools start out being proprietary and then are released to open source later. Next is Hortonworks. Hortonworks was another very huge distribution company. It came from Yahoo. They were completely open source. They both had similar components, but few of the things were different. Even the policies were different in some aspects. Next was MapR. So MapR is not actually based on Apache Hadoop. It is completely proprietary and it is written in C rather than Java. It is integrated to use open source tools like Hive and HBase, but it is basically selected by AWS to provide as an upgraded version of the Amazon's EMR service, which is the Elastic MapReduce service. There was recently a very big merger of Cloudera and Hortonworks. Recently, I mean a year or two back, and they both now come under the banner of Cloudera. So the merger basically happened to be able to compete with the upcoming streaming and IoT, cloud, and these hybrid solutions that are coming up. Some of which are Google Cloud Platform, AWS, and Microsoft Azure. These also provide distributions. So that is it for today's session. And next time we'll be looking at few of the core concepts. Please don't forget to like, share, and subscribe this channel. Give your feedbacks on the comments. If you have some more insights on any of these, please share your thoughts with us. And see you soon. Bye bye.